All right, GM fam, we are live. It is Friday, August 18th. It's 9 a.m. my time. It is some other time if you're in a different time zone. And we are joined by a very, very good friend of mine and one of the smartest engineers that I've ever had the privilege of getting the chance to chat with. So, uh, unfortunately for Charles here, Charles has been like the subject of like a lot of a lot of kind of, let's say, like unfortunate events lately. But like I don't think that any of it is at all his fault. And also, I think that mostly people have moved on because, like, since the curve hack that was like 2 weeks ago, so that's like ancient history in crypto. Anyway, Charles, please welcome to the first llama party that you're part of.
Well, thanks for having me here.
Could you give a kind of brief background of yourself? Who are you? Like, where do you come from? Don't need to dox any details you don't want to, but just whatever you feel comfortable sharing.
Yeah, I'm Charles, known as Big Tech Sucks on Twitter. I've been working on Viper on and off for a few years now, but full time for the last 2 years and some change. And my job, I guess, my mandate is to improve the language and the ecosystem, kind of at all costs. So.
Yeah, and for those who aren't familiar, could you just talk at the high level about like where Viper fits into the Ethereum ecosystem and how it is differentiated in your perspective versus like Solidity?
Yeah, of course. So Viper is a smart contract programming language. It compiles to EVM bytecode and also has another backend to ZK sync. And um, its goal is to be like a clean, um, simple, and high level smart contract language that makes it as easy to write smart contracts as possible. And it focuses on developer productivity and correctness.
And by developer productivity and correctness, like my understanding is that there's like sort of like a few core principles to Viper, right? Like there's the idea that you want to make it easy to write secure code. You want to make it easy for auditors to read that code, right? Like this is some of the design principles.
Yeah, I mean, one kind of principle that I have is that like it's always easy to add more features. It's always easy to make code, more efficient or faster, more performant, or whatever. But it's very, very hard to get code more correct. And so, you know, as much as possible, you know, through ease of writing, making it easy to read, making it easy to audit, Viper is very focused on correctness, which kind of makes it kind of extra unfortunate what happened recently. Um, because that has been our focus for a long, long time, and it highlights how important correctness is actually.
Yeah, and we'll definitely have plenty of time to get into that whole incident. I think before we do, we should just do kind of a bit more like table setting in terms of just describing sort of the nature of Viper, because I don't think people necessarily understand. Like, Viper is basically like a small like open source project, right?
Yeah, yeah. Viper is 100% open source. Basically, 100% of the code I write is public. Um, Viper is a smart contract language, so it's not a general purpose language, but it is supposed to be Pythonic, so it's supposed to kind of look and feel like Python. And, we do try to follow the Python design principles, the Zen of Python. Um, so whenever we're discussing a new language feature or whatnot, it's very often that we go back to the Zen of Python. For instance, like there should be only one obvious way to do things. Simple is better than complex, and so on. Um, And I, as a programmer, really like Python. I think it does a lot of things well. Um, I mean, I have my own quibbles like everybody else, but it does a lot of things well. It makes it, it's a very productive language. It makes it easy to write clear code. Um, I mean, of course, like any other language, there's examples of not so clear code, but um, as as far as the look and feel of the language, um, I'm gonna try to switch my mic to the speaker and see if that helps.
Oh, sure thing. And while you do that, I will see if I can bring up some examples of some Viper code. Just because, like, one of the things that I found really interesting, I have a Python background myself. I think I mentioned to you that back when I was teaching at the University of Washington, I basically it was like the weirdest curriculum because we went through a 3 week program, sorry, a 3 month program in which the boy, I can't speak today. I went through a 3 part program in which the first part was teaching people, some of whom had no experience at all with Python, the nuts and bolts of like how to learn and do some basics with Python. And then the second part of the course was teaching how to like do some advanced data analytics using Python. And then for the third part of the course, it switched gears completely to Solidity. And I was always saying like you should use Python because Viper because Viper's Pythonic. They just spent all this time learning Python, and now you're kind of like rug pulling them by forcing them onto something completely different. But
Yeah, and I would point out that like readability is like a very important focus of Viper. Feedback that I've gotten from a lot of people is that like it's readable to the point that non-programmers can read it. Like if you read an RC20 token contract, kind of does what it looks like it says it does. You know?
yeah, so I'm gonna go ahead and share my screen here because I have, and your mic sounds really good now, by the way.
Okay, great.
So I'm gonna go ahead and pull up this example. This is from the CurveUSD Llama. And you sort of notice right off the bat, like one of the things the documentation mentions pretty extensively in Viper is like a lot of the like best programming practices, which is that Viper really encourages use of like documentation and NatSpec adherence. So here, when Mitch wrote this contract, he started by giving like a very extensive overview of what the variables are supposed to be. So I think this is very helpful because it uses a lot of kind of higher level math. But then as you walk through it, like it's plain English, right? Like it makes sense. Like all these first 100 or so lines is just basically defining what's going to happen in terms of like the state variables for the contract. So it's a lot of declarations. But then as you get into the like actual like not the meat of this, which is like all these different function calls, in many cases like the documentation for each one is almost as long as the function itself. So it's kind of really easy to follow and understand what's going on, more or less. Yeah, this one here gets to be a bit more heavy math, but at least like it's understandable, right? Charles, I can't hear you. I don't know if you disconnected. Hello, Charles. All right, let me see what's going on. Okay, so I think Charles might be having some connectivity issues. We will see. I heard just like a second you came in there, Charles. So while we try and debug this, I will pull up just for contrast a different smart contract, which is one of the more popular smart contracts in terms of just the number of people that use it. This is the smart contract on Etherscan for USDC. Like USDC is like one of the more like commonly used tokens. Hey Charles, I came back for a second. Hello, Charles? Okay, Charles is disconnecting, and welcome back, Charles. You there? Hello, Charles? Hold on a second. I'm gonna have to pop in the video. Um, Let me pop into YouTube real quick. People on YouTube, can you drop in the comments and let me know what you can hear? Hold on a second. I'm gonna have to pop in the video. Yeah, I'm streaming through to YouTube. So, thanks for bearing with us for anyone who's watching. It is 2023 if you're checking your watches, and we still have trouble making video calls. So I guess what I'm contrasting with is like USDC is a very simple ERC20 token, so it's probably not the fair apples to apples comparison against it. But yeah, even reading through it, like it took me several times to like understand what exactly is going on with this contract, and it's kind of utilizing like closer to like assembly language where it's just basically writing stuff directly. And the reason for this is an implementation contract, so you actually have to point to a different address to see the logic because they're constantly changing their logic. So Charles, I saw you flash for a second. Charles, can you say something? Are you there? You're like blipping in for like just a second. Can you hear me? Okay, go ahead.
Mic check.
You're good. You're good. And you can hear me okay, right? Hello? Oh, you can't hear me at all. All right, the fun of live streaming, everyone. So Charles is going to do a quick reboot. He'll be right back. So in the meantime, let me see if I can just pull up ERC20 token within Viper, just so you can kind of compare and contrast the difference between what a ERC20 token looks like. So on Ethereum, I'm going to pull out the
crv. I can hear you again.
Oh, wonderful. I can hear you too.
Yeah, sorry about that.
Hey, no worries. These things happen. So I was just trying to do a bit of code review where you can kind of see the difference between like how simple an ERC20 contract is in Viper versus the Solidity. I was going to pull up the Open Zeppelin template next. But since you're back, why don't you like talk us through like Viper and your thoughts on it? All right. And Charles is going to try again. All right. So, like you'll notice with most of these functions in this ERC20 token, because the ERC20 token is significantly less complicated than the previous one we were just looking at. Like most of these functions, the logic is actually shorter than the documentation. So like this one for transfer from, it's looking at the allowance and then it's transferring. Easy as cake. If it is allowance works, then it sets the approval. Charles, you're back.
Yeah, yeah.
Excellent, excellent. All right, so I've now given the audience who stuck with the technical difficulties a brief crash course in Viper. So why don't you continue on what you were talking about Viper before the issues?
Yeah, sure. So, I mean, what did we cover? Viper is, supposed to be readable, and I think the audience probably maybe got a sense of that through the little brief intro demo that you gave. And yeah, we're really focused on simplicity of the language and trying to make it easy to read and also audit, because that's like the thing that's most scarce is able to get things correct and clear and readable.
Yeah, and I personally find Python to be very elegant to read. Like just the fact they worked indentation into the syntax makes it so it kind of has like you can logically see the structure and the overall flow. So I feel like choosing Python, which is also the choice of like the sort of like the default language for Chat GPT. It's the default for a lot of people who are learning the program. I think it just should make it very accessible to the widest number of people.
Yeah, and a lot of ways that Python tries to do that is it tries to give you abstraction, but with like as little syntactic noise as possible. And Viper tries to align with that as well.
Yeah.
So like if you write a for loop, um, it's basically the least fewest number of constructs that is required to construct the loop, or same with like defining a function or something like this.
Right. And once you start programming in Viper, you also realize that the compiler really pushes you in terms of what it allows, and sort of forces the behavior of kind of requiring people to write good, clean code. Right.
Yeah, and to be quite honest, like Viper actually is restrictive compared to um, other languages. Try to prevent as many footguns as possible, to prevent you know being possible or at least easy to write contracts that are too difficult to follow or too difficult to reason about.
Yeah, like a simple example that I like to give is like you don't allow functions that have too many different return statements in it, right?
Right, right, right. Return statements have to be balanced, so that they all have to be like the same type and the, so that it's yeah, type parameterizable. Um, and like we do things like trace the number of returns from a function to make sure that it's all and we don't allow like dead code after a function return and things like this.
Right, right. And there's like really practical security reasons, which I believe are cited for this, because it's legitimate Python to write a function that then returns and then might have several lines of code after it. But in theory, if you're trying to like sneak something in, you might like have a return statement that returns a malicious value, and then have a bunch of lines of code afterwards, which would be junk. And that maybe the auditor just kind of is so busy reading the extraneous code that they might miss that kind of early return statement. So it's sort of like is just like just like a simple like but obvious way of kind of preventing people from writing code that would be more difficult to audit, right?
Yeah, yeah. I mean, you don't even have to do it maliciously. It's very easy to have dead code. Like dead code can lead to bugs sometimes because like you accidentally re-enable it or something, by deleting the return statement, and then the function performs something different than it originally did.
Yeah, but the nice thing is that the compiler is like, even if you've never written in Viper before, you just start writing it out, and it makes it, yeah, it makes it very clear where the issues are. So I've had kind of no problem when I started out trying to transcribe a Solidity contract into Viper to teach myself. Like, I had no problem just following the instructions the compiler gave back. So it was strict, but it was still like very informative.
Yeah, and Viper does other things like we don't allow for contract inheritance. I mean, we have other plans for code reusability, but so we don't allow like contract or like kind of this kind of storage layout inheritance. Um,
Yeah. So I think I was trying to find a good example of a Solidity contract that has this, but like I despise it when I go to like Etherscan to view a contract in Solidity, and it has maybe like 20 different imports. And when you're trying to figure out what the contract does, you have to like bounce back and forth between 20 different files. Sometimes they're just
yeah,
like Open Zeppelin things that they've imported, and I just find it frustrating.
right, right. And I mean, code reuse is important. So like we do want to make it possible to like import different chunks of code and be able to reuse them and so on. But we're trying to be very, very thoughtful about introducing it into the language, which is part of the reason why, we've delayed so long on doing that. But that's actually something that should be coming quite soon to Viper. I'm quite excited about, the new features and the coding style that it will enable.
Yeah, it's very sad because as of 2 to 3 weeks ago, this was what you were focused on, right? Like Viper 4.
Yeah, Viper 0.4. Um,
So I guess
yeah, I mean, of course, it's real life, right? Like things come up, and we can't just be working on fun features all the time. We need to address other things like, of course, the security of the compiler. We have a lot of things that we're addressing in our process right now.
yeah, so I guess
Um,
maybe like we'll talk about like Viper 4 plans then a bit later, so we can have like a happier ending to this talk. Um,
sure.
but I guess like let's go into the darker timeline. But just before we do, like I'd like to just set the context of, because you were talking about this a bit before the audio issues. Yeah, you have, so you're mentioning how like Viper is an entirely like open source project. Could you give a sense of like the size of the team?
So in terms of full-time contributors, it's actually been me for a while, and then we recently hired somebody to help. This is another thing that I'm quite excited about, but to rewrite the back end of Viper, which is the part that translates. Um, how do I say this? The part. So a compiler has usually a modern compiler usually has several stages. We parse the code, and that's kind of the most straightforward part. Parsing the code, you just turn the 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 source code, which is like a bunch of text, right, into a kind of tree structure, and then you kind of do semantic analysis on the tree to make sure that that the code is well formed and to like basically understand what the user is trying to do. And then you do what's called code generation. So you go into you you convert that tree into an intermediate representation, which is some kind of lower level but not quite bytecode level representation of the code. And then that's where you do optimizations on the code and everything. And then from there, you turn it into bytecode. And so that's the part that, that's one of the things that, the primary thing that we had somebody to help with is that last translation step, because that's where a lot of performance gains can be had.
Yeah, and
And,
just
and that's, sorry, that's usually, so when people like write bytecode by hand and compare it with what the compiler generates, that's usually where there's the most opportunity to get the compiler generated code closer or even better than human written code.
Right, right. And I don't like just for some context for people who aren't coders, like let me go ahead and pull my screen share up again to uh, illustrate this point here. Let's see, where'd that go? Yeah, here we go. So basically, when you're talking about Viper, you're talking about all this, which with this like nice human readable like English text that we can all speak and kind of like even if you don't code, you can kind of look through it and understand. When you're talking about bytecode, this is what it looks like on the actual blockchain. It's just this like string of hexadecimal characters. So I bring this up because like if you are getting into the bytecode, which is what the Viper compiler does, you have to be a very very good programmer, right? Like anyone who's like not very smart like me can like at least look through a like Viper contract and kind of understand what's going on. But you have to be a real expert to understand like when you get down to the bytecode level. So in order to kind of work at Viper, you have to be a top-notch engineer. And I think that you've on some level like you've talked in the past about how it's not the easiest thing to recruit people to work for Viper, right? Because you need to have like very like top level compiler engineering experience and maybe bytecode experience and Python experience. It's like a whole complex skill set, right?
Yeah, working on a compiler is like I want to say really interesting. It's a little bit difficult, but it's interesting and difficult because you have to hold multiple representations of a program in your head at the same time. Like if you're writing a Viper or Python program, you're kind of dealing with source code. And if you're writing bytecode, you are kind of like directly, you're kind of just like thinking about how the physical machine, or in this case, EVM, the Ethereum virtual machine, right? You're kind of thinking about how the machine itself is executing code. Um, to work on a compiler, you really have to kind of hold these two like very different ways of executing code in your head at the same time, and all the intermediate stages. So you have to be able to reason, you know, about how all these very different representations of the code are going to execute. And that's where, the meat and potatoes of compiler engineering is, I guess.
Right. So yeah, it's basically you now and this one other person, and you joined Viper. What it was like about 2 years ago.
Yeah, mid 2021. I had contributed to Viper all the way since, you know, 2018 or so. But I really stepped into this more full time in 2021, and I want to thank Curve and the associated ecosystem for really helping support and sponsor Viper development through this whole time.
Yeah, and I think that's a point that kind of got confused during the actual hack, because one of the challenges with compiler engineering is that like it's not something that's generally been funded in the past by like VCs, right? Like VCs don't put money into compilers, right? They put money into the projects that build on top of the compilers, but like they're all secured at the end of the day by the underlying open source compilers that no one is investing in. So it's like it's kind of creates this like difficult incentives in this like tougher overall system.
Yeah, that's a really interesting point. And, um, a bit of history about compilers and languages. I mean, people used to charge for compilers, like Borland and maybe Intel. I'm not exactly sure on the exact companies, but in the 80s and 90s, people were charging for compilers, and then GCC and Microsoft came out with basically free compilers, and people realized that they didn't really want to pay for compilers anymore. So these days people just kind of expect to use compilers for free, which I think is kind of reasonable. I think you want developers to be able to step into a language and start using it without any like kind of barrier to entry, without any overhead. But at the same time, you know, I think smart contract compilers, I don't want to say more difficult because like any mature compiler project is difficult to work on. But we have some different constraints, which is that smart contracts built compiled with a smart contract compiler could potentially live forever, right? They're immutable. They're sitting on the blockchain forever, and so that you know makes a very different correctness bar. If you have a bug in LLVM or GCC or ICC or MSVCC is that what it's called? The Microsoft C++ compiler, the C# compiler, whatever. Uh, you know, they kind of just patch it and then everybody recompiles their code and keeps running it. That's not a luxury that we have per se. If somebody compiles a contract with, I guess these are infamous now with 0215, 0216, 030 versions of Viper compiler, those potentially live forever. And so the bar for correctness is very, very, very high. And I think that this has caused us and a lot of people in the ecosystem to take, a really hard look about the incentives around, um, you know, these kind of core infrastructure tools that are available in the ecosystem.
Right, and it's one of the reasons Mitch has funded it
Oh,
so.
you're
Oh,
muted.
right. I was just gonna say it's one of the reasons that Mitch has funded this so heavily. He realized the importance of this.
Yeah. And not just Mitch, I want to point out, we're getting, uh, potentially, and I'm hoping this is going to go through, but support from users of Viper, so Curve DAO, Yearn, as well as Lido, I think are gonna, push some financial support for Viper. And I mean, we can talk about this more in a little bit, but I think this also raises the issue of maybe Viper um self-funding, Viper, getting its own revenue to run its own operations. And um, this is not something that, is definitely like something that we're planning, but it's open for discussion. Um, to what extent should Viper have its own revenue, and what business model can we have that makes it self-sustaining and also enables us, you know, to invest in the things that are going to let us do a proper job, security initiatives, maybe, you know, I don't know if it's too early to talk about it, but maybe some kind of insurance for Viper contracts, more tooling, more third-party audits, more internal resources for ensuring correctness of the compiler.
Yeah,
So these are all things that are on the table.
I definitely want to talk about that. I feel like that's like the desserts we need to get to after the hack. Let's go into the hack first, and then we could talk about like the aftermath in terms of like
Sure.
what we could do. Um, so like just to kind of like reiterate a point you made earlier, like Viper is at this point responsible for code that is as far back as like people launching contracts at Viper 0.2.15 all the way through 0.3 point X. So basically, like there's a plurality of versions of Viper bytecode that's been deployed to the chain, um, and some of this even like precedes your time. But it cut to a few weeks ago. You're just going about your day, and at what moment in this kind of like timeline did you hear about like the hacks and that something was wrong with Viper? Like, talk us through like this like day from HE double toothpick.
Yeah. So this is what, July 30th, right?
Mm-hmm.
Um, so I was actually in Pacific time at the time. And I like I like literally woke up, right? And I started looking through my, Telegram messages. And, I noticed something wasn't right, right? Because like Um, I'm getting all these messages. I've been put in some war rooms, and this is roughly an hour after the initial path exploit, right? And I've seen a lot of exploits, but this one looked a little bit different. Um, and people in this war room and also on Twitter were already starting to analyze the exploit, and something was not right. Like this reentrancy thing, like it shouldn't have really been possible, but it was happening. And
And to get the timing, this is after the PETH and the MSETH, but before ALETH. Is that right?
no, about an hour after the initial exploit.
Okay. Because
Um,
Curve had initially posted a tweet back at the very beginning of the PE, thinking that it was actually like a bug in the JPEG code, which they then deleted that tweet when it became apparent it was
right,
like. So this is around the time that it's like someone, you're sleeping at the time, has decided like realized that it's not actually a coding error. There's something wrong with this like older version of Viper, right?
right. So PETH was exploited around 6:10 Pacific time, and I woke up around 7, right?
Mm-hmm.
And people were trying to in this war room. People were trying to figure out what was happening and like able to recreate this reentrancy that shouldn't have been possible. And you know, it took me a few minutes, like to have some coffee and so on. But I was like, oh, right, this this is not right in those versions of the Viper compiler. And so as that started to become clear, you know, this it started to be clear within by 7:30 or so, 7:45 that it was and me and others had reproduced it was a bug in the Viper compiler, and we isolated which versions that it was affecting. Um, and then at that point, you know, so I mean, we first identified that there's this bug, right? And then our focus turned to containment. What versions of Viper are buggy, right? And which contracts uh, compiled with Viper are at risk. And so we fairly quickly figured out that other contracts that were kind of like the same as the PETH contracts were at risk. So we looked at the ALETH and the MSETH contracts and realized that they were at risk. And then we tried, then we were it was a Sunday, right? So we were still like getting organized to like try to figure out what was going on when the MSETH and the ALETH pools were also exploited. And then after a little, I think probably by 8:30 Pacific time, we or maybe 8, we kind of identified that crv.eth, even though because we figured out that most contracts, even with the reentrancy lock, not working properly, most contracts were actually not affected. It was just those that called out to transfer ETH using raw call were affected. In like there's a specific pattern that you have to look for, which is like there's a state change and then you raw call out, and usually the only reason a pool is going to raw call out is just to transfer regular ETH. And so around 8 or 8:30, we identified that curve ETH was also potentially at risk. Um, and we identified very quickly that it's potentially possible to re-enter into it, but it took us a little while to figure out whether and how, I mean so we were in a recovery room, right? And it took us a little while to figure out whether and how, um, you know, funds could actually be stolen, right? I mean, it's one thing to figure out that a contract isn't quite working as expected, and it's quite another thing to be like, I made money, right? Um,
Yeah, because one thing that like people who aren't technical might not understand is that like reentrancy is like it's not like the easiest concept to wrap your head around, right? Like because you essentially have to be like calling a contract and then calling it again within the same block. So it's like fairly difficult to test for using like brownie testing is sweet. It's not like trivial to test for reentrancy.
right, and also all the combinations. So I mean, there's this interesting thing with compilers because the input space is so large, right? You the input space for a compiler is basically infinite. You know, you can take any source code and turn it into bytecode. And so even when there's a bug in the compiler, there's a specific set of conditions that needs to take place for an exploit to actually happen. And you know, that day in those four pools that those conditions were met.
Right.
Um,
And so even at the time, you're just like trying to find the pools that are affected is tough enough because there's not like a directory anywhere of like which contracts were deployed using specific versions of Viper, like that.
there's no, I mean, there are kind of different quote unquote directories, right? There's Smart Contract Sanctuary, which you know has source code for a lot of contracts, and you know Etherscan has source code for a lot of contracts, but these are all not exactly complete, right? Because what's on the blockchain is bytecode, not source code, and so you know in conjunction at you know at a lot of things were going on at the same time. You know, it's not just like we were sitting around trying to figure out how to recover funds from this one pool. You know, we're also at the same time doing like containment. Like we're trying to figure out what other people know. We're you know trying to figure out what we're compiling lists of contracts that are affected. So in a lot of ways we're doing like a lot more work than you know at the same time as any one you know say Black Hat is doing. Like all Black Hat needs to do in order to make money is to identify like a single contract and exploit it. Whereas we're concerned with containment, right? We're trying to identify all contracts and trying to figure out exploits for all of them at the same time, or recovery transactions and um,
It
trying
remind
to evaluate the scope of the situation, like what's at risk.
it reminds me a bit of P versus NP, right? Like verifying versus single solution
You're
is.
muted again.
Oh, forgive me. I was just making a stupid point. I was comparing it to P versus NP, where it's like easy, trivial to verify a prime number might be have a specific factor. Like all you just need to do is run the exploit if you think you have one. But to actually run the entire space of finding all the contracts that might have the exploit is much more difficult.
Yeah, and also I want to point out that we're working with very different constraints than any Black Hat. So like once we identified that the crv pool was potentially vulnerable, we spent some time, it was me and maybe 5 to 8 other people in this recovery room, you know, simultaneously trying to work on a recovery transaction. And we're working under very different constraints because Black Hat is trying to make money, right? And we're concerned with safety of user funds. So one thing that came up is like somebody figured out, um, I want to say shortly at around noon Pacific time, um, came up with a recovery transaction, but it rescued like 60% of the funds in the pool, and we were like, well, um, what? And then we were trying to like figure out the scope of this recovery, like what happens after that. Like, is the pool bricked? Are we able to, you know, um, are we going to be able to? Is the pool bricked? Are we going to be able to recover the rest of the 40% of user funds after that? Like what happens after that? And like how can we safely execute this transaction without getting it front run by Mev or something? And you know like literally in the 2 to 5 minutes while we were trying to evaluate should go forward with the recovery transaction, uh, the unfortunately a black hat exploited the curvy pool with a transaction which looked somewhat similar but not the same as what we had.
Yeah, and I think because it looked similar, I think there was some speculation from people. I don't know if they were in the war room or not, but there's some speculation that maybe someone within the war room was actually like secretly a spy, right?
Right. I mean, like there's always that kind of question, right? Like, how do you know that somebody in the war room didn't do it? But I mean, everybody in the war room was vouched for, and also the structure of the actual exploit. I mean, it was different enough from the recovery transactions that we had considered that it was very unlikely that it was somebody in the war room, and also, people in that room had dealt with exploits of larger scale as well.
Hmm.
So I mean, this is not necessarily everybody's first rodeo.
Got it.
Um,
Got it. Okay. So, all right. So that goes through. You realize you lost by just a couple of minutes, and then is the thought like does the thought turn to like, well, there's still some funds in there. Let's like pivot and try and like get the rest of the funds.
yeah, I mean, I think at that point, it was. I think everybody was a little bit disappointed that we didn't get there in time, but regrouped and we were trying to like, and then we wanted to recover the rest of the funds, right?
Right. So
And
that was
Addison, who I think we had on last week, kind of came out of nowhere actually. I mean, I guess he posted on Twitter and then he was very quickly connected to the Curve team and we got him in the recovery room and was saying that he had this recovery transaction, um, which after a couple hours we were able to a couple hours from the first exploit of the Curve pool, we were able to um, try to run that second transaction, and yeah,
and yeah. So that one, that one again. Addison did tell a lot of the story, but feel free to chime in any details you'd like to add from your POV.
oh yeah, um, yeah, and that was the one which I think got front run um, by Coffee Babe, but I think we're pretty lucky because they returned those funds. Um, so they're kind of the remaining 40% of that pool. Actually, it wasn't the entire remains of the pool. Like there was still some some funds that eventually Addison and Robert were able to recover, but it was a relatively small amount compared to the size of the initial pool.
Right, right. And then there was like a pittance of
Muted
funds.
again.
Ah, jeez. See, you're not the only one with audio issues, but mine are more like brain audio issues, because I forget to unmute. Yeah, the remainder and the curve ETH pool at that point was basically a pittance, which there's still some like, still some attempts to recover that, but by this point, like that first one knocked out most of the funds.
Yeah. The final remainder, which Addison and Robert and I think a couple others were able to recover, was about like $1 million worth of funds, so not trivial. But it was small compared to the original size of the pool.
Okay. So, at some point, presumably, like you're out of crisis mode, right? Like at this point, like crv is like let's say 90% settled, and the other three pools have all been drained. But you know that there's no
We
more
also,
like smart contracts that could be hacked, except for possibly that Arbitrum one.
yeah, and after that, we kind of turned our attention to I mean, that one was interesting because I was saying before that just because you can re-enter into a contract doesn't mean you can drain it. And so we turned our attention to the Tri Crypto Pool and Arbitrum, which we identified pretty quickly that yeah, I mean, you can tell just by reading the code that re-entrance is possible. Um, we couldn't immediately find an exploit, and it kind of became clear fairly quickly that exploiting this was going to be harder. So, several teams were working in parallel on trying to figure out if it was vulnerable. And, um, people in Europe were up until like, God knows what, like 5, 6 in the morning, um, their time. And, kind of people, we were kind of continuing the next day or two to try to figure out if it was exploitable. And basically, our conclusion was that, first of all, it's very difficult. Um, and um, yeah, I mean, the current status of that pool is basically the conclusion is that it's not so easy to exploit, um, if at all. But because the pool, we know that it's reenterable, so it's not functioning, exactly as it's supposed to. So the recommendation is still to leave that pool.
And I think about 90% of people have already left that pool. There's still like $4 million of people who I guess haven't heard the message or just big risk takers.
Yeah, that's about right. Yeah, so the TVL on that contract went from about 40 million on the day of the exploit to now around 4 million.
Okay. So at this point, the situation is, let's say, contained. Is that fair?
Yeah, yeah.
So, what's the war room turn to next at this point? Is it just recovery of the funds, or is it more like doing more of a deep dive into Viper, or is it like different teams like split off and working in different, like in parallel on different tasks?
That's like all of the above, pretty much. There were a lot of different um, people with different kinds of expertise in that war room, and there are some kind of sub teams that kind of worked on recovery, and they did a very very good job actually. So to date, I think like 75 or 80% of funds are recovered, um, either by negotiation or contacting MEV operators, and so they did a very very good job there. And then also, you know, my focus and then some other teams were still working on containment. Like we had done the initial sweep, and those four pools had been exploited, but we were still like some people were still working on searching and trying to figure out is there anything else that's at risk really, and
One,
some small pools were, but yeah.
yeah, one of the most like darkly comical aspects of this whole thing from an outsider perspective is like basically like after all this happened, like I imagine that what Michael wants to focus on is like the recovery efforts. But there was like a solid 24 hours where instead of that, because of his like big position that was getting hunted on Ave, instead he had to basically turn to like quickly like running to manage his position and like quickly fundraise a bunch of capital, just because like that curve ETH source of liquidity on chain disappeared. Um, so, did any of that come up like within the war room where Michael was like, "Hey, I'd like to help, but I have to go like call Justin Sun to wire a OTC deal"?
No, no, that never came up. I mean, like, I think everybody within this nexus was kind of working around the clock. I mean, I know Mitch had some things to deal with, but I mean, he,
But he was still
he was.
focused.
I mean, yeah, he was very, very, very present in the recovery efforts, and you know, nobody nobody in particular was doing everything, right? People were in different roles. There was some. amount of work that had to be done just coordinating everybody, and and everybody was, kind of, you know, there was a lot of independence. People are working on their own tasks, and um, I don't think that Mitch was derelict in any sense of the word, really.
No, 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 no. I mean, he's phenomenal. Like the way that he's able to like keep track of so much going on with the curve. Like, curve is very lucky to have him as a founder. Um,
No, and I mean, like everybody for that first week, I was online 18 hours a day, and I think everybody was. There was just like a lot of work that had to be done.
yeah,
Um,
and we'll move this back to conversation from curve back to Viper in a second. But before we do, like, I asked Addison the same question. Um, like I've been trying to like play the role of like private gumshoe or like mystery detective enthusiast and like psychoanalyze and come up with a profile of who were these hackers, so to speak. Because what I the what I posited to Addison was that there's just like there's a few different hackers, right? It wasn't one entity that just figured this out and like hacked all the pools. Because if there was, it doesn't make sense why they'd return some of the funds and then it'd still be sitting outstanding on Curvy. So I strongly suspect there's like a few different actors. Um, and the way I kind of break it down is like I think there was a first person who didn't understand what was necessarily like there was a code exploit with Viper. I think they just had looked at the Conic finance hack from a week previously and said, okay, it looks like there might be something strange going on with like reentrancy and curve contracts, and maybe ran like some fuzzing tests over like a bunch of curve contracts, and just so happened to stumble across this exploit in PETH, and thus like honed in on that one. And then in my guessing of the situation, like a few other hackers kind of noticed PETH got hacked and kind of started looking into it and figured out quickly how to like run copycat attacks, including like this final group that stole from Curve ETH, which I suspect they got to be like some kind of like serious time player if they're not returning the funds at this point. So I don't know. Like that's just like my like private handicapping. What's your thoughts on like who are these hackers? Am I close?
I mean, I know as much as you do, um, and I think your hypothesis is, fairly similar to mine, and I think that's also the consensus that a lot of people have reached, which is that the initial hack doesn't seem to have been very coordinated. Uh, you know, it seems like they were like messing around with some curve contracts. Maybe they were using a fuzzing tool, maybe it was some sort of formal verification tool, but they found that this contract could be re-entered into, and I don't think they realized it was a Viper issue. Otherwise, they would have been much more coordinated and, probably attacked multiple pools at the same time. Um, yeah, I really, all the evidence points to them not really understanding why, or the root cause of why it was possible. And then, so they kind of exploited it. And then people started analyzing the exploit on Twitter, which, you know, probably wasn't uh, that helpful because I know that, you know, we're kind of racing other actors by seconds or minutes, right? And so publication or public analysis of these exploits kind of only helps the bad guys. Um, and when the race is so tight, it matters. Um, but anyways, I mean, so the exploit started to get public. People started to analyze what was going on, and then I think the Aleth and MSE exploiters were probably not coordinated actors, and kind of did copycat attacks separately. And the struct and then finally the crv exploit, um, it was a technically much more difficult exploit. So it's likely that, first of all, it wasn't exactly a copycat. It was based on the same principle, which is reentrancy from this Viper bug, but it was not a copycat. It was technically more difficult. It was very likely carried out by somebody, an individual or team with more experience. And they didn't make technical errors like getting front run or anything like this. So it's very likely that the curve exploit was, and they also haven't returned the funds or anything like that. So it's very likely that they were a little bit more sophisticated.
Yeah, I
But
mean,
I mean, we don't. I don't know where or who they are or anything like this.
no, it's kind of anyone's guess at this point, right? Like,
Yeah, and it's possible, that some of the um, I was not involved as heavily in the negotiation and after the fact recovery efforts. Um, so it's possible that some people have some more details about that, but as far as I'm concerned, I have pretty much the same information that you do, and I mean we try to. I think it's good that some of this information is a little compartmentalized.
yeah, and I couldn't ask you to speculate because you'd just be like same as me, just like kind of randomly, wildly like guessing things. So who knows if we're right? But I mean, like, yeah, what have you heard like about like outside of that, like just the with the funds that have been recovered, from like the different protocols, like I imagine you got to talk pretty closely with a lot of the founders within these protocols through the recovery process. Like, what's their general sentiment on everything been?
Yeah, I mean they're all just going. I mean it's. I think everybody considers it unfortunate. As far as the recovered funds, they're all going through their formal-ish processes, for redistributing the funds and trying to the best extent possible to make users whole. And it might take a little bit of time because some work some technical work needs to be done, like snapshotting and to figure out exactly who was affected and or which addresses, I guess, and then passing some votes. But I don't think that it will take too long.
Yeah, I was affected by the Curve ETH one, so I'm grateful to hear I might get anything back.
Yeah, um, and I'm not sure this is like super publicized, but the Viper multisig had some curvies, and of course at the time we knew about that, um, but it I mean, at the time, all of our efforts were focused on the recovery. So, I mean, as they say, the captain goes down with the ship. So those funds were affected the same as everybody else.
Yeah, so yeah, it sucks, but I'm just glad to see that Curve at the very least appears to have bounced back. Like obviously, like there was like a really rough week as everyone was withdrawing liquidity and everything, and people were hunting Mitch. But I feel like it's already ancient history. People have forgotten. Curve USD is like nearing 130 million dollars in total supply. So I think, and there's a lot of people like launching stuff on Curve USD. So I feel like the Curve side of things, like somewhat water on the bridge. People have forgot.
Yeah, I mean, it's not great what happened, um, but you know, I think people are very forward-looking, um, and I think at this time our job is to do a really good job in terms of making sure that there aren't similar bugs in other past versions of Viper, and that Viper is, most, has very strong, very robust security and correctness properties going forward. Um, I mean, that's like one thing that this whole exploit highlighted, which is that, it's not enough to just be focused because, in the last couple of years, we have stepped up our game a lot in terms of, getting third-party reviews, getting, much more. I mean, I don't want to say um, that our process was lax before, but right. I mean, in the last 2 years, we have started to get more eyes, more resources, looking at the compiler. But what we've learned, it's not just enough. It's not enough to just, get the current version of Viper better or more correct. Because ironically, like the current version actually is securing the least amount of value, right? It's actually past versions of Viper, which are securing all the value. And so, that's one thing that we're focused on right now, which is actually reviewing um, reviewing kind of all relevant past compiler versions, which could potentially have these kinds of things, and getting eyes on them.
Yeah. So, like, obviously, Curve is very famous for not liking upgradability in smart contracts. Think of it as a bug. But to what degree do you think Curve or other people within the community are rethinking that?
Um, yeah, I mean, I don't think upgradability is great because it allows, one or several individuals to kind of change the code of contracts, which, I mean, it literally breaks the contract between the user and the contract and the smart contract, right? Which is that the code behaves a certain way. Um, but I think people in the curve community are reconsidering, like, to what extent are kill switches useful? Like, even if you don't change the code, can you have like can you cool down a contract for a little while in case of emergency? Um, and there's a lot of different known mechanisms for this, and that are proposed. So like, there's gate seals, there's simple kill switches, there's the circuit breaker. There's a circuit breaker proposal, things like this. And I think those are all things which can help improve um, what happens in emergency situations without breaking, immutability guarantees.
Mm-hmm. Yeah, that makes sense.
You're still muted.
Ah, jeez. I'm so stupid sometimes. Yeah, that makes sense. That makes sense. So that there's like another debate that's been going on. I know, particularly within Curve, about like the idea that like stop handling raw ether. Like if you're gonna use ether, require people do a wrapped ERC20 WEF version of it. And that way you're handling everything as an ERC20 function, which doesn't have it like subject to like basic ETH reentrancy. But you disagree with that, right? Like you still think that handling raw ether is fine.
I mean, yeah, I mean, so there. I think that the issue is a little bit more nuanced than that. So this is not. I mean, the most basic cause of this was the reentrancy lock, you know, not working as it's supposed to, combined with handling of raw ether. But I mean, that's just the issue as a whole is more complex than that. It's not like it's just one class of bug, right? And when we're talking about smart contract correctness, we're not only concerned with one class of bug. We're concerned with all bugs that could affect correctness. And so I think, I mean, and also handling raw ether should be improved a lot with a new opcode that's being proposed. I think it's EIP 5920, the pay opcode, which lets you transfer ether without transferring execution context or without making a call. Um, and but and so that, like, can kind of eliminate an entire class of bugs because you then transferring ether doesn't open you up to reentrancy. Which, by the way, transferring raw ether is like not just with this recent exploit, but it's the root cause of it's the cause of like a lot of reentrancy exploits that are unrelated to Viper or Curve or anything like that. So I think that the payout code, this EIP 5920, is going to improve the situation a lot. But I mean, I think the bigger takeaway is really how to ensure correctness of smart contracts and in general in a very, very robust way. I mean, so you asked what did my attention turn to after, we kind of contained this and, I mean, my focus started to be on like what can we do to the extent possible to make sure that this like never happens again, right? This kind of thing. And one thing that is really going to help, Viper contracts that doesn't even depend on the compiler at all is like kind of formal verification static analysis tools. Um, and if these tools had been available and been for users of Viper, it could be one kind of strategy for mitigating this kind of thing in the future. You know, because there's compiler correctness, and then there's also the availability of tooling, which helps you discover entire classes of bugs that are not so easy to necessarily find by hand, and don't depend on the that are kind of an orthogonal kind of approach compared to just ensuring compiler correctness.
Yeah, one of the things I found really tragic about the fact that Viper got hit by a reentrancy bug from 2 years, version 2 years old, is that before that, like even just like weeks in the weeks running up to this, like Viper had been hosting a very interesting discussion on how to make future versions of Viper like bulletproof when it came to reentrancy. So there had already been the kind of reentrancy guard, which correct me if I'm wrong. I don't think Solidity has like a nice decorator that you could add to a function to make it non-reentrant. But you were basically considering doing that by default and forcing users to make all functions protected in that way. And you'd actually been hosting a poll as to like what was the like gas cost that would make it worthwhile.
Yeah, yeah. So reentrancy is something that is possible at the VM level, the EVM level, and Solidity doesn't provide this natively, although libraries can provide some kind of reentrancy protection. Viper builds it into the language, and actually, the compiler can actually do even more to protect against reentrancy. We can guard an entire contract against reentrancy, and that's something that we haven't done in the past because it's expensive. But these transient storage opcodes, tload and tstore, which are going to be available as of the Cancun hard fork, potentially in just a few months, um, would make the cost of doing that much much lower. So we're talking about going from like 20 off the top of my head. Off the top of my head, I think it's around 2,500 gas to prevent reentrancy into a contract to like 300 gas. And I think the general consensus is that the default, because reentrancy is hard to reason about even for experienced programmers. And probably, the language can and maybe should prevent reentrancy by default and allow it for specific use cases, but it has to be kind of opted into by the programmer.
So I've been trying to grapple with this, and I'm too redacted to figure it out. When does someone want reentrancy? It seems like it's only for hacks. Like I can't think of when it's a good thing.
Yeah, there are specific use cases which you want reentrancy for, um, and reentrancy is a kind of composability, right? It's like so like flash loans, for example, you want reentrancy.
Okay.
Because you call you're inside of your contract, right? You contract X, and then you call a flash loan contract, and then you want it to return control to you um, by extending you the loan, and then eventually you return control back to the flash loan contract.
Okay. All right, that makes
So
sense.
it's not that you never want reentrancy, but you want to do it on purpose. You don't want to have it be by accident, basically.
Okay. All right, that makes sense. That makes sense. It just seems like it's like from the DAO hack at the beginning of Ethereum, it seems like reentrancies caused nothing but trouble. So anyway, I just find it so darkly ironic that Viper was really leading the discussion on how to make contracts safer from reentrancy when you got hit by this 0 day bug from before your time. So it's yeah, it sucks, but it is what it is. All right, so let's talk about the Viper community. How's the Viper community responded to all of this? Because it seems like, from what I've seen, they've been pretty happy. Not happy, but like a rejuvenation of spirit.
Yeah, I mean, I want to say that the response by the community has been very, very good, actually. People have been very supportive of Viper. I think there's been increased attention to, Viper getting the resources it needs in order to, you know, to get the robustness guarantees that people would like when they use Viper contracts. And I mean, there's almost been like an outpouring of support. So different auditing teams, have reached out. Um, different people who maintain different formal verification tools have been reaching out, and actually, we're already the story, the formal verification story for Viper is actually is improving pretty rapidly. Um, at least Certora, like, just straight up has Viper support now, and a couple other tools I think are adding support as we speak. And you know, also, multiple bug bounty and audit competition venues have reached out to us. So I think that there's been expression of a lot of support, and people want to see Viper succeed. So I'm pretty happy with that. And there's as usual interest in new features for the language, and how it's going to improve going forward. So I think in a way, um, Viper is really improving in terms of getting the resources and eyes that it needs to progress as a language and community.
All right. Well, let's get to then the like we talked about it at the very beginning, um, and I think it's like so fascinating. Like I really hope people listen through to the end of this, get past the technical issues at the beginning, and get to the let's call it alpha here, which is let's talk about your plans for getting revenue to Viper, because I've not heard this from any other compiler.
Yeah, yeah. So I think I touched on it towards the beginning, like um, compilers as a business model kind of languished in the 80s and 90s. Um, I think for a smart contract compiler, it makes sense to have revenue and have the incentives aligned with the projects that use Viper, to make it really um, performant and secure. And so there's different um, kind of options that we've thought about and discussed. And I think one that makes there's a few options that make sense, but I think the one that kind of makes the most sense is actually um, for Viper contracts to just be kind of like, you know, all smart contracts charge gas, you know, that goes to the miners that execute them. And I think for smart contracts to be able to charge a little bit extra, between, 0.5% and 3 or 4% of the gas used by the contract and forward it and basically forward it to the Viper community and team in some way, kind of makes a lot of sense to people, especially after, given, the events of these past couple weeks. I think if there's a lot of ways that we can put that money to good use, um, potentially, pay insurance, for, I mean, there's a lot of decentralized insurance, you know, um, kind of projects that have been experimented with. But in principle, like it would be nice to set aside 80% of revenues towards an insurance fund, in case you know this kind of thing ever happens again, and also to just fund better tooling and development of Viper in the ecosystem.
Okay, so this is like really intriguing. So let's break this down. Every transaction using a Viper contract, and I'm presuming that the deployers can opt into this. But if they opt in, their contract is 1% more expensive, let's say, but that contract and its usage is then insured against a potential if that contract is hacked due to a Viper bug, there's a pool of money that will be available to bail the people out.
Right, hypothetically, yeah.
I mean, that's like such an obvious idea to me. Like, if you ask me as a degen, would I ape and be willing to spend 1% gas to know that the contract, if something goes wrong with it, is going to pay itself out? Like, absolutely. Like,
Yeah, I mean, a lot of projects have, the kind of, treasuries or insurance, um, you know, funds or strategies of some sort, and this would just like bring it to the compiler level as well. So it would only be focused on compiler bugs, and I mean,
no, you're not gonna
it
you're not
does.
gonna have any more compiler bugs in my estimation. Like,
Right, right, right. I mean, the idea is no more compiler bugs ever. Um, but, plan for the unexpected. Um, and because I mean unfortunately there's this kind of stark reality of software engineering is that um, bugs do get present in production code sometimes, and they're and, and it's like a multifaceted approach. I mean, we can work on making the compiler more correct. We can get, third party review. We can, get formal verification tools for Viper projects. Um, this would be like kind of like a last line of defense. Like, in case all of those things all go wrong at the same time, um, there would be, something to fall back to. You know, I think that users kind of deserve it, and like there is this perception, and I think it's based in reality that DeFi and smart contracts, there's a lot of risk to using them, and it's for all the reasons that we've talked about so far. And I think that if we want you know smart contracts, DeFi blockchains to really be used to the level that they should, and users should expect some degree of assurance that when they interact with the contract, it's going to do something reasonable, and this is this last line of assurance that we can offer to users, and I think they really do deserve it.
oh yeah, yeah. I mean, well, because like other than this, bug, which in my opinion, very few people could have foreseen. Like, I before this always felt like very safe interacting with Curve because like the programming team had been like so battle tested. And similarly, I even despite this Viper hack, I still feel very confident in Viper and like it's all of its practices. Um, so like the fact that there's this extra level of insurance for like pennies on the dollar, um, like I think is a brilliant idea. As particularly if it's opt out. So if people want to opt out, they can, and you know good on them. They just won't have this coverage. I just couldn't like. Okay, so this money is pooled, and it means then that in the event that like just my contract gets hacked, even if my contract only streamed, let's say, $1 million to this fund, if the fund has 100 million, then my hack would be insurable up to the entirety of that amount, right?
Uh, right, if it's caused by compiler bug. I mean,
Compiler bug
of
only, yeah.
course, yeah, of course, there's, it's an idea at this point. A lot of details haven't been worked out.
Of course.
So, like, how do compiler bugs get evaluated? Under what conditions are are payouts made? Who gets what and when? Who administers it? All of these are kind of open-ended questions, and
Right.
there's a lot of details to hammer out. But yeah, in principle, the idea is to like provide users an extra level of guarantee, an extra level of safety, um, beyond what just us, bringing diligence and care to the table will do.
Can you stake the ether while you wait for a compiler bug, which may never come?
um, let's see.
Because I'd vote yes.
That's a really, I mean, that's a really interesting question, but like, I'm not convinced that we want to gamble with treasury funds, right? Or what if some?
Slashing
I
risk,
mean,
but other than slashing risk, like, doesn't seem so.
right. Insurance companies do this all the time, right? Like they invest their float and um, try to get some return on their float. And I think this is something that Tether is famous for doing. You
Mm.
know, and
Because,
um,
in my opinion, there's not going to be another Viper hack, so you'll just have this pot of money earning interest, which Viper could fund itself off of. Just my 2 cents.
right, right. Well, the whole idea is, if there is a Viper hack, you want
Yeah.
to kind of diversify against these kind of black swan. They're called like black swan events, like black swan events, all occurring at the same time, and like it just seems like Murphy's law. If something is going, if there's some kind of bug in the Viper compiler which is leading to some problems in production Viper contracts, you don't want something bad to happen to the treasury at the same time.
Of course, of course. But yeah,
Yeah.
just food for thought because, like, I could see where normies might think there might be another Viper bug, but I know the Viper team at this point is like getting very streamlined, so I would bet against any more Viper hacks. To be honest, like, I was trying to think. Someone was asking me if Solidity had ever had a compiler bug of this like similar like severity, and I couldn't like. Maybe you know better than I do. I couldn't think of any.
I don't think Solidity has um, had bugs which affect funds at risk. I mean there are bugs in the Solidity compiler sometimes. As I mentioned in the beginning of this conversation, a lot of factors have to kind of align in order for a compiler bug to turn into funds at risk, and they haven't done that yet. And I will go on the record saying, um, I do have my own disagreements with the Solidity team and the language and so on, but But I will say I have quite a lot of respect for the Solidity team. They're very very diligent about correctness. They're very very careful um, when it comes to securing the Solidity compiler. I don't have anything bad to say there at all. Um, they do a very very good job in that regard.
Yeah, well, I think that's fascinating. Like, I think the idea of like if you build this business model around Viper, and have like a sustainable source of funds to put back into the project, as well as like, give users a real value add for using Viper, which is this extra peace of mind which no one else could offer. Like, I think it's gonna be a game changer in my opinion. Uh, would this come with a Viper token?
I think this, I think the standard response is there is no token. I mean, I think if a token made sense, we might try to figure out how to do that. But but that adds additional layers of complexity, um, of course. But I mean, it could also be something very interesting, at least to think about. Um, I mean, that being said, my comments just now, I don't think any pilot team is immune from having bugs, ourselves included.
Of course,
Um,
of course.
so which is why you know even if we do our even if we do our best, or another team does their best, like is very diligent and applies all the tools available to them. Um, and I'm talking about the Viper team as well. Um, Bugs can still happen, and that's the entire idea behind this hypothetical insurance fund.
Of course. I get that you're representing Viper, so you have to like discuss all these risks. I am an idiot, so I can just say I know you. I know the team. I don't think there's gonna be Viper hacks.
We all hope that's the case.
um, this is very cool. I've been taking up so much of your time here. I know that I promised you it'd be like an hour. We're going on 2 now. So I don't want to like use up too much of your Friday, and especially because I think you said you were like on the East Coast, or not to dox your location too much. But just anything that like you wanted to throw out there on the record, or like clarify for people, or just discuss that's on your brain, that we didn't get a chance to talk about, or that we were supposed to and I forgot.
Um, I think we've covered pretty much, everything that's relevant here. I want to thank you for having me, and for discussing all these things that I haven't really gone. I mean, I've gone on Twitter and said some things, but I haven't gone into as much detail as we've gone here. So, um, thanks for setting this up, and 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 helping to discuss with me, and making this public, because I do want to let people know that Viper isn't going anywhere. You know I'm working as hard as possible, and everybody involved with Viper is working as hard as possible to make it. I think that everybody involved with Viper wants to make it the best possible smart contract language. S- space grade, easy to use, robust, really productive, and we're just gonna keep working on that until I think the cows come home.
Well,
So
as a loyal Viper user, I'm very very excited to hear that. So thank you so much for coming and sharing. Like, feel free to anytime you want to talk with some people, feel free to give me a shout.
yeah, thanks so much for having me.
All right, everyone. It is Friday, August 18th.